Hello everyone. Let's begin. I hope you have some energy left after many talks for roughly 2 days, but this will be fun. Some years ago, I was working for a small company with a big problem. So this company I was working at was building an e-learning platform, and the goal of this platform was to show the exact right e-learnings for every user in a personalized manner. And these e-learnings were the ones that they had to complete or redo to be allowed to do their job. So many of our clients were in healthcare, for example. This is really very relevant for nurses. So what's the problem? Well, the problem was our product wasn't working. So that was a slight issue. It didn't start out that way, of course. I've worked there for quite a few years, and in the beginning, everything worked okay. But over the years, the product became more complex. New rules, new features were added, and this made it very hard for developers to keep everything in their head and keep everything working. So that was a problem. And at some point, it was so bad that we as developers, we started our day, we deployed a new feature the day before, and we were actually scared to open the backlog because we knew that when we deployed, we had broken another feature. So that's a big problem, and we had to solve that. So we as developers got together and we said, okay, we need an entirely new solution to avoid us introducing all these problems. And we analyzed what we had to do because we had a database, and the database was full of personalized information about our users. And what needed to happen was whenever changes were made in that information, one way or another, the e-learnings of the users had to be updated correctly. And we as developers kept forgetting certain rules, and this went wrong. So we were looking for a way to execute certain logic whenever a certain record in the database changed. And luckily I had the best idea to do this, because I had learned about something magnificent called database triggers. Amazing SQL scripts that you can automatically execute whenever a record in the database changes. And we thought, okay, we have it. This is the idea. So we will move all our fundamental business logic to database triggers. And all our problems will be solved because we can't forget it anymore, right? So it's perfect. And we did. And many problems were indeed solved. However, it is the worst mistake I ever made during my entire career. Hi everyone again. My name is Ruben Scheedler. I'm a software developer from the Netherlands working for CodeClan. And I love programming. I really do. I love everything about it. I've been doing it for, I think, 15 years for something right now. Started in high school for fun, worked for 10 years now at several companies, different stacks, different sizes, small, large, enterprise. And I still love it. And the thing I like the most is the architecture of the system, because it has a lot of influence over time. Decisions that you make when it comes to your software architecture really matter. So that is what I want to talk to you about today. First, let's think back to the story I just told you about the database triggers. Like I said, it was, I think, the worst mistake I ever made in my career. And there are a lot of reasons why it was such a bad decision. I'm not going to tell you those reasons. You are going to tell me those reasons. Because we are going to play a game I like to call the roast of Ruben's trigger solution. So you will be given a limited amount of time to come up with as many problems that you can come up with about putting your business logic into database triggers. What problems do you think as developers we will have encountered after doing this? What quality attributes do you think we lost when making this decision? So the last group I did this with, in just over a minute, got to at least 10 problems, and it was a small group. This is slightly larger. The record is at 12, and that was just 3 people. So I have high expectations for you, and we are software developers, so we like roasting other people's code, right? So I will start the timer in a few seconds. Raise your hand if you have an idea. Keep your response brief, and we will get to as many answers as possible. Okay, are you ready? No, all right. 3, 2, 1, let's go. Anyone have any idea? Yeah, I see a hand.
Good luck with the testing of the business logic when it's in database triggers, so it's not easy testable.
That is correct. That's 1. Testability. Yes, circular triggering. Yeah, and that leads to another problem, but that's 2. Yeah. Any more? I see a hand there. Yes, exactly. True. 3. Performance, yeah. That's 4, I think. Yeah, that is definitely true. Unfortunately, I experienced that. Yeah. Yeah, it's hard to find specific developers, so that's like 6 or 7, I think. Yes, there was a complete lack of debugging as well. We used tables actually for that. It was terrible. That's true as well. All right. Well, you got to 8, so that's pretty good. Can this please turn off? Sorry for that. All right. Good score. Good score. Why I wanted to play this game is because it gets you in the mindset of thinking about what do I expect of a software architecture, of a good, well-designed system. And I was thinking about this question a year ago, and I was scrolling on the internet. I ended up on Wikipedia, and I came by the story of Odysseus, the old Greek hero. It's a fictional story of Homer called the Odyssey. And Odysseus, he was the king of Ithaca, a Greek island. And he went to war. He went to Troy. He fought in the war. He won the war. And his plan was to sail back to Ithaca with his crew and be king again. Should be easy, right? I mean, the war should have been the hard part. Well, it took him 10 years to sail back from Turkey to Greece, to Ithaca. And that was not entirely due to Google Maps not being invented, but it was mostly because Poseidon had cursed him, which meant that during his journey back, he encountered all sorts of problems, mythical problems. He had to fight a cyclops and all other sorts of mythical creatures. And that got me thinking, because a good architecture should help us do something very similar. Odysseus was a hero, and even though it took him 10 years to get back home, he overcame all those problems that he encountered. And a good software architecture should be like that as well for us, because when we are building a system, we don't know the future. But the one thing that we do know is that there always will be challenges when we develop this system further, and they sometimes are of epic proportions as well. And what we expect of a software architecture is that it helps us overcome those challenges. So what we are going to do today is I brought 2 architectures for you, layered architecture and hexagonal architecture. And we are going to send them on an Odyssey as well and see how they perform. So both architectures will have to go over 3 challenges, 3 similar challenges, and we will see how they do and how they compare. And after that, we will have a demo of an application that was built with hexagonal architecture, because that is often the lesser known architecture. Can I see some hands who have used some form of layered architecture in a system? That is a lot of hands, which is predictable. How many have used hexagonal architecture? Well, that's quite a few. Nice to see. Yeah, let's get going. Let's move to our first hero, layered architecture. But before we send it on an Odyssey, let's quickly recap what layered architecture is about again. So, layered architecture dictates that we separate our application code into vertically stacked layers, each with its own responsibility. The foundation of this architecture is the data layer, responsible for interacting with systems like databases. And then on top of that, we have a business logic layer containing the business logic or your domain. Then above that, we have a service layer, which is typically responsible for, well, orchestration of flows, like the starting point for behavior that needs to be executed. And then finally, on top, we have the presentation layer for interacting with stuff like the UI. Now, an important rule of layered architecture, and this was told in a previous talk in this room earlier today as well, is that each layer only knows about the layer directly below it. That's a very important concept. And that, as a whole, makes layered architecture. So, let's put it to the test. When Odysseus had set sail from Troy, wanting to go home, he was sailing for 2 weeks and no island, nothing to see, and they were running out of food, which became an issue. And they were sailing, and eventually one of the crew members looked over the ocean and they finally saw an island. Great, maybe they have food. So, Odysseus set sail to this island, but he was a bit wary because he didn't know which island this was. So he sent out a scout, which disembarked of the ship, went into the jungle, and Odysseus, well, he waited until the scout reported back. And he waited, and the scout did not return. But Odysseus is a hero. So he said, "We leave no man behind." And together with the rest of his crew, he disembarked as well. And he went through the jungle looking for the scout, and eventually, unfortunately, he found the scout completely high, because this scout had encountered the locals of this island, Lotus Island, famous for the lotus fruit. And what the lotus fruit does when you eat it is that it makes you completely forget what is important in life. So the scout was simply forgetting about Odysseus and his ship and whatever. He was just being happy, eating fruit with the locals. Well, Odysseus was a bit mad, of course, so he dragged the scout away from the fruit back to the ship, and they set sail away from this forsaken island. So, what does this have to do with software architecture? Well, one thing that we expect of a good software architecture is that it tells us what is important in our system. And it makes sure we never forget what is important in our system. Now, what is the only thing, the most important thing of every system? There is just one answer. And that is the business logic. That's the whole reason your system exists. You are automating something typically from the real world. Now, the good thing about layered architecture is that it isolates the business logic in a separate layer. It isolates it from other concerns that are less important. But this architecture does not scream, hey, the third layer from the top, that's the important one. It doesn't. In fact, it makes it very tempting to make you believe that the data layer is the most important part. It's the foundation. And if you recall the story I started with today, that is exactly what happened at the company I was working at. We fell into the trap of database-oriented development. We started with a data model, and then we built our way up through this architecture, but it makes you put more emphasis on the data layer, more than is needed. So, tough challenge for layered architecture, but we will move on to the second one. When Odysseus continued sailing, he eventually ended up at a new island. This time it was the island of Aeolus, god of the wind. And Aeolus looked at Odysseus and he said, "You're a cool guy, I like you. So what I will do is I will give you a bag." Okay, a bag. Well, the bag contained all the winds except for the tailwind he needed to arrive home. That's clever, of the god of the wind. So Odysseus, he accepted the bag, of course, and he set sail with, who would have expected, a tailwind. So the journey was pretty easy. He sailed to Ithaca, and eventually he looked through his looking glass and he saw again an island, and it was Ithaca. And the whole crew got very excited, of course. They made it. I mean, they had to sail like 1 kilometer, but what could go wrong, right, in the last mile? Well, they started partying. So they look through the ship and they find all this wine and rum, and they start partying, and Odysseus joins in as well, but eventually he gets tired, so he started sleeping. They were almost home already, right? So no problem. And at some point they run out of wine. So the crew starts looking for more wine, and they see this mysterious bag on the ship. So what do? They sit down and they open the bag, and all the winds come out, form a gigantic storm, and this storm, just before the shore of Ithaca, blows the ship all the way back to the island of Aeolus, where they started. And Aeolus, he sees him, and he's like, "You're cursed. I'm not helping you anymore." And Odysseus had to continue his journey on his own. So what does this have to do with software architecture then? Well, many developers and even architects are tempted to believe that in their system they also always have a tailwind. And by that I mean that information flows in the direction they like, which is from UI to an application to a database, which is often the case. But in modern day landscapes, there are many systems for which this is simply not true. So, for example, we've heard some talks about event-driven today. What if we are dealing with a message queue instead of a UI? So we are reacting to a message and we are not receiving some API call from a web page. Then Martin Fowler has said, well, everything that has to do with a message queue is put in the data layer. And yeah, I agree, it's sort of a data system. But now when we are reacting to a message coming in on a topic here, and we want to start a flow, we should do that from the service layer. So are we going to call the service layer from the message queue then? That goes quite completely against the whole idea of layered architecture. So maybe we should put the message queue on top. We should put the code like in a presentation layer or something, because, well, we want our tailwind. We want our information to flow from top to bottom, right? Yeah, it could work. I mean, it's ugly, but it could work. And then what if a different use case in the same system wants to send a message instead of reacting to one? Then we want the code of the message queue to be in the bottom again. So this is just a small example of showing that layered architecture doesn't really help us when information is coming from different flows, so from APIs, from message queues, from process engine, etc. But let's move on to the third trial of our Odyssey. Eventually, Odysseus does reach Ithaca. Actually, he's actually on the shore, he is home. But it's been 10 years. So he doesn't know what happened in those 10 years, right? So he disguises himself and he sort of does a bit of awkward walk by his palace to see, is my wife alive? Is my son alive? I don't know. Well, the good news is his wife is alive. But the bad news is there are a lot of strange men wandering through the palace. Strange men trying to convince Penelope, his wife, to marry them. Suitors. Well, Odysseus is mad, of course. He doesn't like this. So he confides in his son. He says, hey, I'm your dad. I'm back. Yeah, it's been 10 years. Yeah, sorry. But we need to do something. We need to do something. So they organize a tournament for the hand of Penelope. And the winner of the tournament then would, of course, get to marry Penelope. Well, Odysseus, in his disguise, participates. All the other suitors join in. Odysseus wins the tournament, of course, and as a sort of, I don't know how to call this, like a dad-son bonding experience, they decide to murder all the other suitors. Personally, I think it's a bit exaggerated, but, well, that's what happened in the story. Okay, so what does this have to do with software architecture? Well, one of the most heard and important principles in software architecture is the single responsibility principle. So we compartmentalize our application into different modules and we say, hey, this module is the house of this responsibility and only of that responsibility. Now, what happens when Odysseus went away from his home island? So no one was taking care of this principle. Things started to leak in, and this happens in software as well. You start out with nice clean components, but you develop your product and suddenly those lines that started out as black become gray. And that's an issue. And a good software architecture should help you protect against that happening. Things getting tangled up, getting coupled. So how does layered architecture help us in this situation? Well, there are some good news and some bad news. So the good news is we have these different layers with different responsibilities. And when it's set up well with nice abstraction in between, that works. But again, if we are dealing with an application in a modern landscape that has to deal with more technologies than just a simple API and a simple database, what happens then? So what if we have a REST API and a GraphQL API and a message queue and a process engine and a file system? How does layered architecture help us provide the separation we want between those technologies? Well, it doesn't do a great job, because if we have two APIs, well, we bring them in the presentation layer, sure, that's fine. But nothing in this architecture makes sure those two don't get mingled up. Sure, you can be a disciplined engineer and you can divide them, but you expect from your software architecture to help you with that process. And the same goes in the data layer. That concludes the 3 trials for layered architecture, the Odyssey. Odysseus was home, he was king again, with his wife Penelope. So let's move on to the second architecture that I brought to you today, hexagonal architecture. And again, let's first go over the basics of this architecture. How does it work? Hexagonal architecture dictates that you split your application code into 2 areas. So we have the hexagon, which is the house of your domain, and only your domain. And around it is a sort of a mode of abstraction. We will come to that later. And then we have adapters. So this architecture is actually based on a design pattern from Alistair Cockburn called ports and adapters, which explains, well, the adapters. And every adapter is a component that houses the code of one technology. So REST, for example, one adapter for the REST API. And then these, of course, need to communicate with each other. So the adapters need to be able to call behavior from the domain. And this happens via input ports. In other words, use cases. Use cases execute stuff in the domain, but sometimes also want to request something from the outside world. In other words, from adapters. And whenever they want something from the outside world, the domain defines an interface, an output port, which is implemented by one of the adapters. The domain doesn't care which one, it just knows there's an implementation for it. And that as a whole forms the basis of hexagonal architecture. So let's put it on the same Odyssey as we did for layered architecture and see how they compare. First, the Lotus Eater. So how does hexagonal architecture help us remember as developers what is important, help us protect our business logic? Well, that's quite easy because hexagonal architecture screams what is important. It is the domain. It's in the center. So that's clear. And that's nice. Then we move on to the second trial, which was Aeolus, God of the Wind. So how does hexagonal architecture help us deal with information coming from all different sides? Well, it does so by not caring at all where information is coming from. So we have behavior defined in the domain, in use cases, and any adapter is allowed to call a use case. So it doesn't matter whether information is, whether use cases are called from a REST API or from a GraphQL API, or even from a message queue adapter, for example. So this gives us flexibility. Thirdly, the third trial, Penelope and the suitors. How do we make sure that our architecture protects the single responsibility principle so that one component has one responsibility? Well, again, it does a better job because every technology that we use gets a separate adapter instead of having to share a layer with other technologies. And this makes sure that the technologies don't get mixed up. And it's actually very easy to swap out technologies. So if I want to switch to a different message queue, the impact of that change is limited to one adapter only. Nice. So now we have looked at two architectures. We sent them on the Odyssey. We see how they held their ground for multiple trials. And now let's start looking at some code of hexagonal architecture. So I created an example application. It's on my GitHub. You can find it there. It's written in Java. And let's go over how it's structured and how typical flows would work in reality in such a system. First, the broad structure is as you might have expected it. So we have a domain and we have an adapter package. The adapter package contains several different adapters, but let's first start at the domain. So we have our typical domain models. Not very complicated, not very interesting. But what is interesting is the ports folder. So we have the separation that you might have expected. We have input ports and output ports. And whenever I encounter a new application that I have to sort of master, I have to start working on, this is the first place I go to, the input ports, because it shows you sort of like a menu of the functionality that the application has to offer. So in a very brief time, it helps you understand what the application is responsible for and what it's capable of. And in this case, we can see that it contains all sort of use cases for task management. It's quite clear from this. You can complete, create, delete, etc. But let's zoom in on one of those use cases. Now, something fun to know and to remember is that every use case typically looks the same. So if you've seen one use case, in some way you've seen them all. There are 3 typical stages that every use case contains. The first would be to retrieve some domain objects from the outside world. The use case wants to make modifications to them, so it fetches them. That's stage 1. Stage 2 then would be to apply business logic to those objects. So here we see some check, and then the task is being completed. So that's stage 2 of a typical use case, business logic. And then finally, when those changes are made, the use case wants to make this known to the outside world again. So it wants to publish these changes, and it calls an output port for that as well. Again, it's not known what's after this port, and the domain doesn't care. But these are the 3 typical stages you see in a use case. So that's nice, but it's only half of the puzzle, right? So it's always nice to see an entire flow from start to end to really grasp how an application is working. So typically in real life, I would just go check the references of this use case, but for now I will show you the path I'm taking. Use cases are called from adapters. That's a fact, at least. So in my case, I know that this use case is at least being called here in the web adapter. So this adapter houses a REST API. Everything that has to do with REST and controllers, etc. is here. And we can see that our use case is being called here. So this is the start of a typical flow, like you probably are used to, even if you're working in layered architecture. Use case get called. There's some validation here, but not business validation, simple validation. And let's jump back to the use case and see what's behind these magical doors, right? Because we've looked at the use case itself, but we don't know what's behind these interfaces. Again, what we do know is that these interfaces at least will be implemented in adapters. And in this case, these 2 are implemented in the persistence adapter, because they are about fetching and saving data. So there is a class here in the persistence adapter, and it implements the ports that we were looking for. A few notes I want to make here. Many frameworks that we like to use, in this case it's Spring. It's a very much used framework in the Java landscape. Offers us all these nice tools. So in this case, it offers us a CRUD repository out of the box, so we don't have to type anything ourselves, and we can just use that. And that's nice. I recommend using that sort of stuff. But if you are working in hexagonal architecture, make sure you only use that sort of stuff in the adapters. So the interfaces are segregated from each other, so getting and saving, etc. are all different interfaces, but I still get to use that nice CRUD repository, but behind a wall of interfaces. Another thing you see here is a mapper, and that brings me to a point of criticism that is often heard when talking about hexagonal architecture. And it goes like, there is so much mapping going on. I am only writing mapping when working in this application. I mean, it's sort of true. There is a lot of mapping going on, but it's for a reason, because there is very strict separation between the adapters and the domain. So when transitioning from one to the other, you will likely have to map your data, and when going back, that goes as well. But what I dislike about this criticism is that if you use layered architecture in the right way, you will roughly have the same amount of mapping going on, but then just between layers. So keep that in mind. All right. Then I want to touch upon a small extra point, because sometimes you have to deal with cross-cutting concerns. So, for example, what if I have a use case and I want it to be executed like a transaction? The implementation of something being executed as a transaction is typically done with a framework, right? So I don't want that in my domain. That's why I placed it outside of the domain here. So I made an extension of the use case, while the business logic is still in the domain, but sort of the transaction layer around that is placed outside of the domain. You could choose to place this in an adapter, that's fine. In my case, I use a Spring Boot application, so I placed it in a configuration package, but the point is, at least don't place that in your domain. All right. Let's wrap this up. If my internet would not have been gone. Let's try this again. Luckily, I have a backup. All right, so what did we talk about today? Well, we talked about two architectures, layered architecture and hexagonal architecture. And we put them to the test. We made them go through 3 trials each, and we saw how they put up. We saw that layered architecture had some challenges with this, and that hexagonal architecture had an easier time helping developers with all these problems that we typically encounter. But why do we care so much? Is this really important? And today I want to close with a news article that I read just a week ago. And this news article was about the Dutch tax agency. And the news article said that the tax agency had just told our politicians that it cannot process any major reforms in the next 5 years. Think about that. So we live in a democracy. We choose politicians, and these politicians might say, hey, we want to lower taxes on fruit and vegetables. And then the Dutch tax agency has to say, well, we can't. Sorry for your democratic process, but we are too busy with the last change you asked from us, which also took us 5 years. We as software engineers are building the digital infrastructure for the next decades. And if you are building on these systems, you have a responsibility to try and make these systems able to change, to avoid these types of situations. Think about what software architecture you are going to choose and make sure it is able to deal with a lot of changes, because it matters. And when you pick your next software architecture for your next system, I'd like to ask you to consider hexagonal architecture to be your next hero. Thank you for your attention.